Today's fuel systems include many components such as fuel tanks, lines, hoses, fittings, fuel pumps, injectors, injection pumps, and primary as well as secondary fuel filters. Also, some of today's engines are fitted with fuel-water separators. Proper filtration of fuel systems is necessary to keep engines running efficiently. To understand how the fuel system works, let's take a look at a typical diesel engine. Fuel is drawn from the fuel tank through the primary fuel filter on the vacuum side or upstream of the fuel pump. It then passes through the fuel pump and onto the secondary fuel filter, located on the pressure side or downstream of the fuel pump. Next, the fuel flows to the injectors in the cylinder head. Surplus fuel that is not sent to the injectors and burned in the cylinders flows back to the fuel tank.
In a modern gasoline engine, the fuel pump is typically located inside the fuel tank. Fuel is drawn from the fuel tank and passes through the inline fuel filter. On some automobiles, the inline filter is also located in the fuel tank. This is a non-serviceable filter. The fuel then flows to the injector rail and injectors in the intake manifold. Surplus fuel that is not sent to the injectors and burned in the cylinders flows back to the fuel tank.
Fuel filters perform similar tasks to lube filters. Both physically remove particulates from a fluid stream. As a fuel filter becomes plugged, the equipment operator may notice a gradual loss of power. This is very different from a plugged lube filter, which can go unnoticed until engine damage is discovered during servicing. While lube oils are refined to be highly pure and virtually free of contaminants, diesel fuels are not because of the use of heavier crudes. This is why you'll find number 2 diesel fuel to be one of the most variable fuel sources on the market. Even the API regulations allow certain levels of contaminants to remain in the fuel. Typical contaminants in diesel fuel include precipitates and particulates, wax, water, and microorganisms. Precipitates, such as water, are suspended contaminants in fuel. Precipitation can be accelerated by significant temperature changes. Particulates, or asphaltenes, are black, tar-like contaminants which are residue from the refining process. Both are non-combustible materials that form when fuel oxidizes or when two incompatible fuels are blended together. Because precipitates and particulates are typically heavier than fuel, they tend to settle to the bottom of the tank and can be extracted. Wax, in moderation, is a desirable fuel component because it adds energy. However, as temperatures fall, wax changes form and can create problems in the fuel. The temperature at which wax begins to form into solid crystals is the fuel's cloud point. The fuel appears opaque but is still fluid. The pour point, or flow point, is the temperature at which gelling occurs and the fuel can no longer be poured. As wax gels, it can restrict and ultimately stop the flow of fuel through the filter. Water is the most prevalent and potentially the most damaging contaminant. It destroys the lubricating properties of your fuel, which can result in scoured pumps or blown injector tips.
Water is found in the diesel fuel system in two forms, emulsified and free.
Emulsified water is a result of the refining process and cannot be easily removed from the fuel. Free water can get into the fuel when the temperature outside changes and condensation results. It can also enter vehicles and storage tanks during fuel transfer. At extremely cold temperatures, water in the fuel can freeze and contribute to total fuel flow stoppage.
There are three common methods for water removal from a diesel fuel system.
Stripping uses a silicone-treated media that strips and collects the water, but allows fuel to flow freely. Coalescing is the settling and collection of water droplets by using gravity and low flow. And absorption uses a filter media that absorbs water and allows fuel to flow freely. Microorganisms are colonies of fungus and bacteria which live in water and feed off of the fuel's hydrocarbons. Commonly called humbugs, These colonies of organisms spread in the presence of water and can be passed on from one fuel tank to another if a fuel filter is not used. As the microorganisms accumulate, they spread through the fuel system and can quickly plug the fuel filter. The only way to eliminate bacterial and fungal growth once it has started in a diesel fuel system is to treat the system with a biocide.
To remove water from gasoline fuel systems, a fuel additive can be added to dehydrate the fuel. These additives also have the ability to keep the fuel from freezing in the gas line. Hastings manufactures a wide range of fuel filter products to help keep your engine running efficiently. You will learn more about how to choose the right filter for your application in the Filter Types section.